Welcome to Pikes Peak Library District's video badging for the Lulzbot TAS 3D printers. After watching this video and answering the questions on the accompanying tests, you'll be ready to come into the makerspace and use the 3D printers for your own projects. You can also use this video to review the printing process if you've already been badged, but maybe forgot a few of the details. First, let's talk about how the PPLD makerspace works and what's required to use the space. There are two things that everyone who uses the 3D printer needs to have. First, you must have an individual PPLD library card in good standing, meaning that you're not blocked from checking out materials due to fines or for any other reasons. When your print is finished, we charge money for your print based on its weight by putting a fee on your card, so if you've already got too many of those, we don't want to stack on more. Your library card must also be your individual library card. You can't use your parents' or your spouse's or your kids'. Although many families like to use one member's library card for their whole family, we don't technically issue family cards, and in order to track that you've been trained to work on the machines, you'll need to have your own. If you don't yet have a library card, stop by one of the service desks and we'll get you set up. The second thing you need is the Makerspace Safety Use Agreement and Liability Waiver. Some of the machines in the Makerspace can be dangerous if used improperly, so we've got to get our legal bases covered, make sure that you know the risks, that you take responsibility for using the machines properly, and that we can get you medical help if you need it. Once we've got this on file for your account, it's good for all the tools in the space. For everyone's safety, we do have age restrictions for minors in the makerspaces. You've got to be over 9 years old to be in the makerspace at all. Ages 9 through 11 must be accompanied with a parent or guardian at all times. The parent must be badged on the same machine as the child so that they can properly supervise usage. And ages 12 through 17 can be in the makerspace by themselves once they've gotten their waiver signed. Once you're in the makerspace, you want to make sure that you're wearing closed-toed shoes that won't present a tripping hazard. That means no sandals or high heels. In the case of an emergency, you'll want to alert a staff member, but for your own safety, also make sure to take note of the location for the fire extinguisher, the first aid kit, and the eye wash station just to the right of the entrance. Before you come into the makerspace to use the 3D printer, make sure the makerspace is going to be open in the first place. Unlike most of the rooms in the library, the makerspace is only available during certain hours, so you'll want to check the calendar for the Make 2 open hours. Use of the machines is on a first-come, first-served basis, so it pays to be the early bird. We don't have a specific time restriction on how long you can use the 3D printer, but one rule we do have is that you must remain in the room to monitor the entire print. You can leave for very short periods of time to go to the bathroom, get a drink of water, or grab a book, but you shouldn't be leaving your print unattended for more than a few minutes. This rule helps us make sure that no one user monopolizes the machine by putting on a huge print and then leaving, and it also makes sure that you'll be here to fix or restart your print if it goes wrong. If you do need to print a larger object and you don't want to sit around waiting for the whole thing, you can always stop by our Makerspace service desk and request our drop-off 3D print service. When you come to use the 3D printer, bring your library card to check in with a staff member and let them know which machine you want to use. We have two machines you can choose from, the smaller TAS Mini, which you can bring to the desk and hook up to a laptop, or the larger TAS 6, which you can use at one of the stations. Once they're hooked up to a computer, both are pretty simple to use, but the TAS 6 can handle larger jobs. Either way, we'll get you set up with a laptop if you need it, and a kit of all the supplies you'll need for using the machine. Inside the kit, we've got gloves to protect your hands from the hot end of the machine's nozzle, a spatula to remove the prints from the printing bed, tweezers in case you need to remove any stray or dangling plastic from the bed or nozzle, and flush cutters for cleaning up your print after it's done. A 3D printer can't print anything without instructions. It needs a file to tell it what the object should look like. So first, you need to get yourself an STL file. Well, where do you get one? The easiest way is to just download an STL file from the internet. Thingiverse.com, for example, has hundreds of files that you can browse and download. Or you can make your own file from scratch using any number of CAD programs like Tinkercad, Onshape, or Fusion 360, or a digital sculpting program like ZBrush, Meshmixer, or Blender. Basically, anything that can export an STL file. Check the links below this video to see our recommended software and links to our favorite beginner tutorials so that you can start making your own files. Before you go and grab just any STL file, keep in mind that not all models are well suited to 3D printing. Rendering a model on a computer screen is one thing, but bringing it to life is another. 3D printing is still an imprecise, sometimes inconsistent technology that doesn't always give you exactly what you envision. Sometimes prints will fail by accident, and sometimes the printer just can't print the model you want no matter how many times you try. Depending on what you want to print, you may need to reconsider the size and shape of the object and the precision with which you need it to print. By far, the most common reason that a 3D printer fails to print an object is its size. Just because a 3D printer is technically big enough to house the thing you want to print doesn't mean that it'll print effectively. As the plastic cools, prints can start curling up off the plate. At first, it'll just be the corners of the print, but sometimes the whole thing can just come right off. The bigger a print is, the more likely this is to happen. Once you get over about 6 inches long or wide, you're looking at some potential curling issues. A tall print can also be problematic, but as long as you're not relying on a lot of support material, you can usually get away with it. Also remember that printing can take a while, so a large object could take several hours, even if it prints correctly. So I just mentioned support material, but what is it? Well, when you're 3D printing, you're building a model from the ground up by dropping layers of molten plastic on top of each other. That means that in order to build, the plastic always has to be landing on something. You can't just deposit liquid plastic in midair. If you're building something that has an overhang, or a piece where the plastic is supposed to hang out in midair, you're going to need something to build on top of that you can remove later. That's where support material comes in. Support material is a fragile plastic scaffolding that is created to provide support underneath the region where the overhang will be printed. It will print under any overhang greater than 45 degrees. There are 3 big disadvantages to support material that make it a good idea to minimize how much of it you'll need to print. For starters, support material tends to be printed in a more clumsy manner than the plastic that's actually part of the print. That means it can sometimes collapse or print incorrectly before it gets tall enough to actually support the object it's supposed to hold up. Support material can also be printed in places that are hard to reach, making it difficult to remove. For example, if you were printing a wiffle ball, support pillars would print inside the structure, and you'd have to use some very precise tools to dig in there and get it out. Lastly, when printing fragile objects with very thin overhangs, sometimes the process of removing support material can stress those thin parts and cause them to break. Sometimes you can avoid printing support material by rotating the object so that it prints in a different orientation to reduce the number of overhangs. And sometimes there's just nothing you can do, and your object will require a lot of support material no matter what. The good news is that you don't have to design the support structure as part of your STL file. Just design the object you want, and the printing software will calculate for you where the support material is supposed to go. Cura is the software you'll use to prepare the printing plate. We don't recommend trying to prepare your print at home, though, because your version of Cura won't have the same settings as ours. Just bring your STL files and be prepared to arrange the print here at the library. Once you're ready to start preparing your print on our laptops, look for this icon on the computer's desktop and double-click it to launch Cura. When it opens, start by selecting the printer that you plan to use. You'll either be using the Lulzbot Mini or the larger Lulzbot Taz 6, which you can find by clicking Settings at the very top of the screen, navigating down to Printer, and choosing the one you'd like to use. Then, on the top right of the screen, make sure that your settings look like this, with Category set to All and the material set to ABS IC3D. It is very important that your print is set to the right material or else it is likely to fail. Depending on what kind of print you want, you can choose either the standard detail settings, high speed, or high detail. You also definitely want print support structure checked on. This will ensure that your print gets support material underneath overhangs as needed, but will leave overhangs of less than 45 degrees alone. You can also choose whether you want to print with a brim, a skirt, a raft, or just straight on the plate. We recommend printing with a skirt, which helps the extruder clear out old plastic stuck in the nozzle. Once you've set your basic settings, go ahead and load your STL file on the preview plate. To do this, click the Folder button on the top left and find your STL file in the folder browser, either on your flash drive or on a folder on the computer if you've created it here or downloaded it from the internet. When you load your model, Cura will take a moment to analyze the STL file and give you a time estimate of how long it'll take to print and how much it will weigh based on your current settings. You can find those estimates on the bottom right of the preview window. To navigate this workspace and better arrange your print, you can change the angle of your camera by holding down the right mouse button and orbiting around the preview space. You can also use the mouse wheel to zoom in and out so that you can get a closer look at the preview page. To add multiple objects to the plate, just go back to the Folder button and choose another STL. Just remember though, more files will take longer to print, and detail may be sacrificed if the nozzle has to travel between multiple items printing at once. If you click on your model, you'll see the buttons on the left side of the screen light up. Let's take a look at these functions. Although you can already move objects by just dragging them around the plate, You can access fine controls through the Move button that allow you to reposition the object with exact measurements. You can click and drag one of these arrows to move the object along that axis, or you can type in a specific distance. Most of the time, you'll want the object to print directly in the middle of the plate, but you can try moving to a different part of the plate if you need to make room for multiple objects. The Scale button allows you to adjust the size of your object. You can drag these handles that appear on the object in and out, or you can type in a specific measurement in millimeters for its height, width, and length. Either way you choose, if the Uniform Scaling button is on, it'll make it so that any adjustment you make to one axis will be proportionally adjusted on the other axes. We recommend leaving this on unless you intend to stretch or warp your object. If you want to bring the object back to its original size after scaling it, there is a button to reset the scale. You should never press the Scale to Max button, though, since the printer will never be able to complete an object at maximum size. You can use the Rotate function to reorient your print. Click the Rotate button, then slowly drag one of the 3 colored circles to spin the object around that axis. If you don't like the results, you can click the Reset button, and if you'd like for the software to try finding a flat surface near the bottom of your object, you can hit Lay Flat, and it'll rotate the object a little bit to try to print on a flat edge. The Mirror button will give you 6 directional options for reflecting your object across an invisible mirror plane. You can also use the Multiply Object button to quickly create additional copies of your STL. There are 3 ways to view your object in Cura. The default solid view, which we see here, simply shows you the STL that you've loaded. Any red surfaces you see in this view are regions that the software is counting as an overhang. You should expect these surfaces to rest on top of support material. You can use the View Mode button on the left to learn more about how your object will print. The X-ray view is useful for examining any internal cavities in your model. And the Layers view will allow you to survey your print layer by layer, showing you where support material is going to print and what the object looks like on the inside. You can use the filters in the pop-up to choose what operations will be displayed, and your slider on the right side of the pop-up to view a cross-section of each layer in the print. You'll notice that most objects have this hollow, grid-like fill anytime large areas of plastic are printed. This lattice work is called infill and helps reduce the amount of plastic required to print your object, as well as saving on print time. Even at a 20% infill, the grid structure will give your model enough support to withstand most normal use. But if you're interested in making a stronger object and don't mind the extra cost or print time, you can increase the fill by choosing one of the options on the right. We recommend 20%, 50%, or gradual, but avoid zero infill, as your object may collapse during printing. After you've examined your print and your settings, take one last look at your preview time. Remember that your print needs to be completed before the end of Make 2's open hours, so make sure you've got enough time left to complete the print and clean up your station. We charge 5 cents per gram for the final product, including any support material, so you can also get an idea in advance of how much your print will cost by checking the estimated weight. When you're satisfied that everything is ready to go, make sure that your printer is turned on and connected to the computer via the USB cable. Then, press the Print Monitor button on the top right corner of the screen. This screen is called the Print Monitor. Now, the first thing to know about this screen is that as long as the status bar in this light green region at the top says Connected via USB, you can go ahead and start your print right now. You don't have to mess with any of these other buttons unless you need to change the color of the filament in your printer or move the nozzle position for some other reason, for example, to move the nozzle away from a print after you've paused or canceled. Let's start by talking about manual heating. When you start your print, the printer will use your materials settings to automatically handle temperature management during your print. So what's the purpose of heating things manually? Well, for starters, it can take a good 5 minutes or so to heat the bed temperature up to the required 100 degrees that it will need to reach before the printer can start depositing plastic. If the bed temperature is already at 100 before you hit print, it can save you a few minutes of waiting around. It's not a big deal, but if you want your print to start as soon as possible, while you're arranging the plate or grabbing a different color plastic, entering 100 into the build plate temperature slot and hitting preheat can save you a little time. That's really all this button does though, so don't worry about it too much. You can also preheat your hot end or nozzle. This won't necessarily save you too much time while printing, but it is essential if you need to change out the color of your plastic. We'll talk about this more in a bit. Now, in my opinion, the buttons down here in this region, heat extruder and heat bed, don't make much sense as they pretty much just duplicate the functions of the preheat buttons up here. I recommend making temperature adjustments up here and using the buttons in this region strictly for moving your nozzle. In this region down here, we have a couple of directional buttons that you can use to move the nozzle forward, backwards, left, and right along the X and Y axes. And these up and down arrows that control the Z-axis movement will adjust the height of your extruder. The way these buttons work is that when you press one, they will move the nozzle by a number of increments equal to the number in the move length box. So, if you have a 1 in here, pressing one of these arrow keys isn't going to move your nozzle very far at all. I recommend making movements at increments of 10 instead. If you plan to change the plastic that's loaded on your machine, it's a good idea to have the nozzle in the center of the X-axis so that you can have full access to the mechanical components of the extruder. These buttons, retract and extrude, turn the gear that drives the plastic in and out of the nozzle. When you hit extrude, the printer will pump some plastic through the extruder and it will come out through the nozzle. Retract will pull the plastic up out of the extruder and back onto the spool. Either way, it's important to note that the plastic cannot move in or out unless the nozzle is at its melting point. So before hitting extrude or retract, make sure that your hot end has preheated to 240 degrees Celsius. When the target temperature is reached, you can hit the retract button to unload the plastic currently in the nozzle. We recommend retracting in increments of 10 in the extrusion amount slot, since increments of 1 will take forever. Keep retracting until you can easily pull the plastic out of the extruder. This is done by turning the 2 thumb screws on the top of the extruder assembly, loosening and unbuckling the filament clip that keeps the plastic in place. As you do all this, make sure to keep your hands away from the hot end of the nozzle as well as the bed plate if you've begun preheating it. Make sure not to let the filament get tangled as you're putting it away. If you simply let the plastic relax on the spool, it'll probably get tangled, so what you want to do instead is take the end of the plastic filament and pass it through one of the holes on the rim of the spool. That'll keep the end of the plastic held in place and prevent tangles. Tangled plastic will mess up your next print, so it's also a good idea to double check that the plastic you're about to load unrolls freely from the spool without any kinks or tangles. It's a lot harder to do this after the print is started. The filament you'll be using is 3mm ABS. 3mm refers to the diameter of the plastic. The spool itself may say 2.8 or 2.85mm, but 3mm is the industry shorthand for this thickness. ABS is a petroleum-based plastic found in many common household items like the keys on a computer keyboard, covers on wall sockets, or Lego toys. You'll find the plastic rolls sorted into these labeled bins. Remember that you're looking for 3mm ABS, but if you have any doubt, you can also ask the staff member at the Makerspace desk to help you pick the right one. Once you've chosen the color of ABS that you'd like to print with, it's time to reload your filament into the printer. Ensure that your temperature is still steady at 240 degrees. Also, make sure that the end of the filament is cleanly cut, free of any dangling globs or stringy plastic. Insert the plastic into the feed hole in the extruder. Then rebuckle the clip, loosening or tightening the 2 screws if needed. Click Extrude to begin feeding the plastic through the nozzle. Again, this may take 2 or 3 extrusions before you're ready. You want to see plastic flowing out of the nozzle in the color of the filament you just loaded in. Remove this plastic and you're ready to print. Click the Print button and the printer will start its routine. From here on out, the printer pretty much takes care of everything. Now, it may take several minutes before you see anything happening because the plate and nozzle have to heat up first. Both of these components will be very hot, so make sure to keep your hands away from them or any moving parts on the machine. The TAS Mini and the TAS 6 both have their own methods for cleaning off the ends of their nozzles, so don't worry about trying to remove the dangling bits of melted plastic. These printers are also auto-leveling, so if you're used to a printer that requires leveling, don't worry about it here. The only thing you can really do while a print is in progress is pause the print and retract or extrude. This might come in handy if you need to swap your filament out halfway through, either to load a different color or untangle a kinked spool. You may also need to do this if you start running low on plastic on your spool and need to load a new one. Just keep an eye on your print and watch out for curling. If your print does start to curl up from the plate, you may need to cancel the print since there's really no fixing it. Pushing the plastic back down against the plate won't work, I promise. The best you can do is try the print again, modify your design, or let a staff member know if it's a recurring problem so that we can take a look to see if there's a problem with the printing surface. When the print is finished, wait for the plate to cool down. Then use the spatula provided in your kit to gently remove the print from the plate, making sure not to scratch the printing surface. Bring your print up to the staff desk and let us weigh it so that we can charge your account. When you're ready to head out, make sure you've got everything you brought in, pack up the kit, and return it to a staff member. Check out and enjoy your print. And that's it. Now you're ready to take the quiz, make sure your waiver is completed and signed, and see a staff member to get your library card marked with your certification. Once all that is done, you can start printing on the Lulzbot TAS printers at Library 21C. Hope to see you in the Makerspace soon.